So this week we're going to work in lesson 56, and I've kind of broken it down. I think we'll probably spend 3 days in this lesson, and I hope most of it is review. I know we've graphed linear functions and x to the power of n functions and square roots and absolute values. And I think possibly you've already done some work with the sine function. Um, and 1 over x. So that leaves the floor function as kind of, I think, one that you maybe haven't seen in the past. And so I just want to today review just a few of these. On Tuesday, we'll take a look at a couple more, and on Thursday, we'll do the last couple. So pretty straightforward. Not a lot for terminology for this lesson. As a matter of fact, there is no new terminology at all for this lesson. So your assignment is going to be very similar to what we're going to do here. Graph a function. In this case, we're going to graph f of x equals x. Find where it is increasing and decreasing. Find its maximum value and minimum value. Find its x-intercept and y-intercept. Find the domain, find the range, and find any symmetry that it has. Hopefully, on the base function, graphing, I hope, and especially for linear functions, should go pretty smooth. Okay. Other functions, you may want to pick some values and plug them in. But for f of x equals x, we have the intercept is at 0, 0. The slope is 1. So hopefully we can just use the slope and the intercept to draw the graph. If you do not have graph paper at home, you certainly can just sketch it on your notebook paper. That's not a big deal. But then we need to answer some of these questions. So, where is this function increasing? And I'll let you tell me, and then I'll laugh at you. No, and then we'll write down what the interval is for increasing for this function.
It's increasing above the x-axis and decreasing below it.
So remember, we're talking about going left to right. So as that graph goes left to right, does it ever decrease? Or is it always going up as we go from left to right?
Oh, wow.
Okay.
I guess
And
it's always going.
Yeah. So that's a very common mistake, is especially when we put that arrow at the end, and that may have been what, so it's going down, but it's going down as we go to the left. And we always want to talk about moving left to right. So it's increasing everywhere. And therefore, it's decreasing nowhere. Nowhere. That is terrible. There we go. That's a little bit better. All right. What about minimum and maximum values?
Would the minimum be negative infinity and the maximum be positive infinity?
That is a great thought. But because negative infinity and positive infinity are not actual values, they would not be minimums and maximums. But you've got the right idea. It's going to go off as high as we want it to go and even higher. So in this case, there are none. There are not any minimum or maximum values. All right, x-intercepts and y-intercepts. Where do we cross the x-axis?
At 0.
Yep. I'm going to write it as an ordered pair. And likewise, the y-intercept is 0, 0. Remember, the x-intercept is where the function equals 0, and the y-intercept is the value we get when we plug. No, let me try that again. No, I think I had it right. The x-intercept is where the function equals 0, and the y-intercept is the y value when we plug 0 in for x. Just want to make sure I had it in the right order. I shouldn't doubt myself. Well, yeah, I should doubt myself. Sometimes I mess that stuff up. All right, domain. What values could I plug in and get a real number answer?
Domain, I think, is all numbers. Well,
Yep.
infinite.
Yep. You could write all real numbers, or you could use the same interval notation that we used for the where it's increasing. So you could say negative infinity to positive infinity, or you could write out all real numbers. Yep. And then what about the range? What about output values or y values?
Would it be the same?
Same thing, all real numbers. All right, and then the last bit, does this have any symmetry? Ooh, that one was really bad. So remember that there are two types of symmetry that we've talked about. One is for an even function, it would reflect over the y-axis. And the other is for an odd function, which reflects over the origin. So in this case, it reflects through the origin. In other words, if I put a mirror, I'll draw it in red. If I put a mirror like right here, I would get a reflection of the other side of the line. So that's the linear function. Again, I think I can be pretty confident that you can graph linear functions. Okay. The great thing is with a linear function, the increasing, decreasing, minimum and maximum is going to be true for all linear functions. The domain and range will be the same for all linear functions. X-intercept and y-intercept will depend if we shift that line around at all, it could change those things and the symmetry could change as well. But the increasing, decreasing, minimum, maximum, domain and range will always be for a linear function, those exact same answers. All right. So let's go to a little bit different function. The function 1 over x, sometimes called the reciprocal function. How comfortable are we with the reciprocal function? We've graphed these before or no? A little bit? Okay. One of the things that's always important, especially when we have a variable in the denominator, is finding the vertical asymptote, the value for x that makes the denominator 0. So I'm actually going to start with that. And what number would I plug into the denominator to make it 0?
0.
0. Yeah. Excuse me. Then we can also talk about horizontal asymptotes. And that just means if I plug a really large number in, like 1,000,000 or 1,000,000,000 or 1,000,000,000,000, what happens to the value of my function? So think about what happens if I plug in 1, I get 1. If I plug in 10, I get 1/10. If I plug in 100, I get 1 over 100. If I plug in 1,000, I get 1 over 1,000 and so on. What's happening to the value of that function? What value are we approaching as x gets larger and larger?
Decreasing.
It will be decreasing, yep.
0.
Yeah, it has a horizontal asymptote at 0. All right. Excuse me. For things like maximum and minimum, well, we see we have asymptotes on the X and Y axis. So will we ever cross the X and Y axis? So in this case, no. Oof. All right. As far as other values go, if you're not comfortable with a function, a great way to graph is just pick some values for X and Y. Because I have that asymptote at 0, I should probably pick a couple of negative values and a couple of positive values. So we can do that. I think our author in our book calls this the shotgun method. So let's pick -10, -1, -1/10, and then we'll pick the positives as well. So 1/10, 1, and 10. So if I take -10 and plug it in to 1/x, I get -10 in the denominator, so it's -1/10. I'm going to switch colors for this just to show that. And if I plug in -1, what value do I get? 1 divided by -1.
-1.
There you go. And what about 1 divided by or 1/(-1/10)?
-10.
Yeah. So one reason that we call this the reciprocal function is because our y values are just the reciprocal of our x values. And see, you guys let me get away with graphing this wrong. I don't know. Should be -1/10, should be on the negative side. -1 and -10. So the left-hand side of this graph looks something like that. Okay. And what's going to happen with the 1/10, 1, and 10? So go ahead, Emmett. It looked like you were going to say something. I didn't mean to interrupt. Maybe not. So, go ahead.
Oh, and just be the same as the previous answer. It's just not negative.
You got it. So we'll have +10. +1 and 1/10. All right, so we want to talk about, and actually, we already answered um, increasing and decreasing. I think we said that already, that it was always decreasing. And that would mean it's increasing nowhere. We got the intercepts, minimum and maximum. What is the smallest Y value that I can get? What is the largest Y value I can get? Again, there is not a minimum or a maximum. All right, domain, range, symmetry. So for domain, what X values can I plug in? Or sometimes it's easier to say, which ones can I not plug in?
X can't be 0.
Right. And the way that we're going to say that is using that set builder notation. Our domain is all X's such that X is not equal to 0. And what about our Y values?
Is that the same? It can't be 0.
You got it. Y such that Y is not 0. All right. Symmetry. Again, in this case, we have kind of mirror images. It may not look like that because Mr. Gingrich's drawing isn't real good, but we have mirror images through the origin. So the symmetry is through the origin. All right. Just a little bit and then we're done. Yay. On this one, I think let's try to graph it without listing everything, and then we'll come back because on your assignment, you're only going to be asked for the domain and range. So I think if we can graph this and then just find the domain and range, we'll be in good shape. So this is x squared. What do we call the shape of that function, x squared?
Parabola.
It's a parabola, correct. It has its vertex at the origin. And if you remember, there's a special pattern that it follows. We go over 1, up 1, over 1, up 3, over 1, up 5 in both directions. If we have an even power, what's going to happen to that parabola? It's going to widen out. So x to the 4th would be a little bit wider, x to the 6th would be a little bit wider, and so on. What is the domain? What values can we plug in for x?
I think all real numbers for the domain.
Yep, all real numbers. Perfect. What about for the range?
The range has to be greater than 0.
I'm going to make one little adjustment to that because it could be equal to 0. Otherwise, perfect. Perfect. So that's your domain and your range. This one is an even function, so it has symmetry across the y-axis. We don't necessarily have to write that. And then because y is greater than or equal to 0, it does have a minimum. Kind of cool. All right. X cubed, do we need to see x cubed, or are we comfortable with, if you can react and give me a thumbs up, I will skip over x cubed. Yeah, thumbs up, there's one. Is anyone else on still?
Can you go through X cubed?
I can.
Okay.
So for x cubed, again, I would probably, there's no denominator, so we don't have to worry about asymptotes. So I would just pick some values, like maybe -2, -1, 0, 1, 2. And if we needed more, we could certainly use more. But that's where I would start. So I would take -2 cubed. -2 times -2 times -2. That would give me a -8. -1 cubed, -1 times -1 is 1, times another -1 is -1. Tough one here, 0 cubed.
Here.
0, okay, good. 1 cubed. And 2 cubed. So if we graph that, -2, -8, -1, -1, 0, 0, 1, 1, +2, +8. Oh, let's try that again. Would look something like that. Domain, what are the X values that we can use here?
All real numbers.
All real numbers. So if there's not a vertical asymptote, trying to think if then we're going to have all real numbers. And what about the range? All real numbers, Mr. Gingrich? Yes, it's all real numbers. Perfect. All right. Malachi, was that good?
Yeah, that's good.
Excellent. So a little bit of an assignment today. On 55 Part A, you're just given those same four functions, sketch a quick graph. And then for 55B, they're adding things to the function, whether it's a constant in front, or they're adding something or subtracting something. So it's going to move the function a little bit, but it's working with those four functions that we worked with today. As soon as you have that written down, you are free to go. I know I went over today by like 10 minutes. Shame on me.